Okay, we're in this packet, surface area of rectangular prisms. We went through pages 1 through 4 yesterday. We're going to start on page 5 today. This says we're going to find the surface area of a rectangular prism. Now this one by now should be pretty easy for you. I'm doing number 1, and all the rest should be about the same.
Is that the ES1?
It says ES1, integers ES1, rectangular prism. Okay, and the numbers on here are 13 inches, 9 inches, and 3 inches. And we're supposed to find the surface area. Now there are 2 different ways to do this. You have a formula to find the surface area of a rectangular prism. It's the perimeter of the base times the height plus 2 times the area of the base. Okay, this is the formula that's on your formula sheet, so we will use that. I will tell you that if you have a problem remembering how to use this formula, then all you have to do is take this piece apart and make the front, the back, you're tearing the box apart. Here's the front, here's the back, here's the top, here's the bottom. These are the shapes when I tore this apart. And then you have the side and another side. Rectangular prism will have 6 pieces. When you do this, you simply put the numbers on here. This is the front. So the length is 9 and the width is 3. The back of a rectangular prism is going to be exactly the same, so you have 9 times 3. Now let's go to the top. That's this part. So we need to figure out the dimensions of the top. Now if this is 9 inches, so is this one. And the width, if this is 13, then this is 13. So you have a 9 by 13. And the same thing here, a 9 by 13. And that should be, okay. And then the side, here's the side right here, which is another rectangle. And you can do 13 by 3. And the other side is going to be identical. There's that line I was missing. 13 times 3. So what you're going to do here, if you're tearing the box apart, this is if you don't remember the formula, okay? This is if you don't remember the formula, you can do it this way. So 9 times 3 is 27 square inches. The back is going to be the same. This is in a rectangular prism. 9 times 13 is going to be 117, I think. Yes. And the bottom, 9 times 13 is going to be exactly the same. The side is length times width is a rectangle. So we have 39 here, square inches, and 39 square inches here. And so you simply add these up. 27 plus 27 plus 117 plus 117 plus 39 plus 39. So we have 18, 25, 32, 39, 46, 6, 8, 9, 10, 13, 16, and 3 inches squared. Okay, that will be the total surface area, remembering that surface area is only the part that you'll paint. It's only the part that you'll paint. There's a lot of people snuck in while I was gone. While I was gone. Okay, but this is the way that we use the formula, okay? And we'll have to remember what the letters stand for. So this is the most important, because you all have gotten really good at using a formula. You just have to remember what the letters stand for, okay? In this case, of course, surface area, the P stands for the perimeter of the base. The perimeter of the base. So the base, let's call it the bottom. The top and the bottom are the same, so you can look at it. We've got to find the perimeter of this. Y'all see? So how do you find the perimeter?
By adding the sides.
Add all 4 sides. Be careful not to fall into the trap that some people do. They see the 9 and the 13 and they simply add that and stop. Okay? But the perimeter is all the way around. So we've got 9 plus 13 plus 9 plus 13. Okay? And so that should be 44. Write this down if you need it. This small p means the perimeter of the base. The perimeter of the base. Did y'all add that?
Yes.
22. So it is 44?
Yeah.
All right. Times the surface area equals 44 times the height of the prism. The height of the prism. So in a rectangular prism, it's the other number. Okay? So we found the perimeter of the base, and the other number is what connects the 2 bases together. Okay? So there is, so the height is 3. Okay, plus, I'm just following the formula. The 2 is in the formula, and then the big B stands for what? The area of the base. That's correct. So I have to find the area of the base. Capital B means the area of the base. And we already found the area of the base, didn't we? The area of the base is length times width. Okay, length times width. The area of the base is 117. And so all I have to do now is my multiplication. So I have 44 times 3 should be 132, I think.
Yes.
Plus 234. Am I correct? You guys are going to have to correct me.
132. Yeah, that's right. The 32.
Okay.
Was.
And then when we add these 2 together, our total surface area is 366.
Yeah.
Well, I'll be darned. Would you look at that? So we can either use the formula, but if you forget what P is and you're not really sure, then tear the box apart, because no matter which way you do this, you're going to get the correct answer. Sound good? Okay. I don't see anything else on this page, but I did think of a vocabulary word that I need to make clear to you here. Surface area means all of the surface that I can paint, right? Surface area means all of the surface that I can paint. There could be a vocabulary word, lateral surface area. This one, when they say surface area, it's total. They won't say it. They won't say the word total, but it means everything that could be painted. Lateral surface area means everything that can be painted except the bases. Okay? So the lateral surface area would not contain this or this. Okay, lateral surface area is everything except the bases. Okay, just in case you see it, not sure that you will. Okay. I need you to know everything. Okay, so I'm going to tell you everything. Are there any questions on this page 5? Any questions on page 5? All of these are going to be the same. The word problems, please do not skip the word problem. The word problem will be done exactly the way this is. Just as you see it, draw your little picture. You do not have to be an artist. Just draw a picture, put the dimensions on it, and work the exact same way. Don't be scared of the words. You guys are big kids now. It looks like the next page is exactly the same. It says, except it uses decimals, okay? And if you're using your calculator, decimals is not a big deal, okay? Remember your rules for decimals. If you have any problems, let's get on Essential Ed and study the decimals, practice those, or ask me for a worksheet, and I'll get that for you too. But if you're using a calculator, this is no problem because it's done exactly the same way. So now I'm at page 7. Page 7, again, it has more words, but all you have to do is, it's this one. Up at the top, it says fractions S1. Fractions S1. And the only difference here is they're using fractions. That's it. There are more word problems, but all you have to do is draw yourself a little diagram, okay? It doesn't have to be perfect. Put your dimensions on there. It's done exactly the same way we just did on the board. All right? So you should have everything you need. I'm moving through this because there's a couple of really important things I want to tell you at the end. And I'll just let you look at the YouTube, okay? All right, now I'm on this page that has a surface area of a triangular, but it's still a prism. It's still a prism, okay? The reason that it's a prism is because it has 2 bases, the one on the front and the one you can't see on the back. Triangular. It is page 8, okay? If you numbered your pages. Christopher, remind me to get you a packet if you don't have one. You have one. Oh, you'll need one of these. Okay, so remind me about that, okay? All right, on this one, and we'll work one if you want to. We'll work one.
What's the number to that? I don't have it.
Number,
Page 8.
it's page 8 and the top just says sheet 1. It's triangular prisms. Triangular prisms, it says sheet 1. We're going to find okay, for a triangular prism, look on your formula sheet. This is a little bit misleading, but right here on your formula sheet, it's right in the middle, y'all, where it says surface area, and then directly underneath it says rectangular / right prism. A right prism can be any of these prisms where the height is perpendicular to the base. Okay, that makes it a right prism. It's not squished over for some reason. Okay, a right prism is everything that we've been using up until now. So when we're working with this triangular prism, we can use exactly the same formula because the triangular prism is a right prism. Y'all see, that could be confusing on your formula chart, but I'm telling you. Okay? All right, so let me try to draw this. I'm doing number 1. And I have 12 inches here, 10 inches here, 14 inches here, and then they're showing us the height of this triangle, and it's perpendicular to the base, so that makes this the height, and it's 8 inches. Okay, and we're supposed to find the surface area of this triangular prism. So what we're, again, this is a right prism, because if you stood this on the end, this 14 inches would go straight up from the base. It would be perpendicular to the base. That's what makes this a right prism. Okay, and so we're going to use this formula over here, the same thing we used for the right rectangular prism. So surface area equals, and the P stands for the perimeter of
The base.
the base, the perimeter of the base. In this case, the base has to be the 2 ends that are each other and that are parallel to each other. So this rectangle could not be a base, do you see? Or this rectangle that it's sitting on could not be a base because there isn't another one that's parallel to it. Has to be the triangles. So the triangle is the base. The P says to find the perimeter of the base. Now in this case, just making sure. This is also 10 inches. We could use Pythagorean theorem to make sure that it is. I think so. 6,
5.
hopefully.
Yeah, we did this one.
Okay, so the perimeter of the base is 12 plus 10 plus 10. The perimeter is all the way around the base. 12 plus 10 plus 10 is 32. Then times the height of the prism. That's not the 8. It's not the 8. The 8 is the height of just the base. I want the height of the prism, which is our other number, 14, plus 2 times the area of the base. This is where you have to take a side trip and you say, okay, where is the base? What shape it is? What formula do I use to find the area? So I need the area of the base. Here's our base. What shape is it? It's a triangle. How do you find the area of a triangle?
Area equals 1/2 base times height.
That is exactly right. And when we write the formula now, it's just time to plug in. So we have area equals 1/2. The base is 12. The height is not this one. This is called the slant height, and we actually will use it later. But the height they're talking about here has to be perpendicular to the base. I kind of covered it up, but yes, it's 8. And so the area of the base, which is our big B, is equal to 48 inches squared. Now this is our side trip, because what we're trying to do is find out what the big B is in our formula. This is what the big B is in our formula. Okay, so we have 2 times 48. Somebody's going to have to do this one for me. 32 times 14. Can't get that one in my head.
448.
What is it?
448.
448? probably. I was estimating in the thousands. That's not, I was wrong. So this multiplied together becomes 448. This multiplied together becomes 96. When we add those two together, our surface area for this triangular prism, it's a right prism, equals 544 inches squared because we're finding area. Do y'all see? Any questions? Christina, Josh, Isabel?
No, ma'am.
No, I'm good.
So I'm not going to tackle any more on that page because they're all done exactly the same way. Okay? Any questions on that page?
On 5.
Number 5?
Yeah. I
Okay.
had a hard time with 5 and 6.
All right. We want to do 5, number 5. So our picture for number 5 looks like Deborah. And then comes down like this. And oh, yeah. All right. And this is 12 inches. This is 7 inches perpendicular to the base, 11 inches, and 9 inches there, 19 inches here. I think I got them all.
Yeah.
Okay, again, the triangular prism, triangular prism means that the bases are triangles. See, they're equal to each other and parallel to each other. And it's a right prism. I don't think you're going to have something that's not a right prism, okay? So you can use this surface area for all the prisms on your test. Does that help?
Yeah.
Okay. So what we're going to do here is follow the surface area problem or formula equals the perimeter of the base. This is our base that we're talking about. So the perimeter of the base is going to be like 32 again?
Yeah.
Yes. 32 times, this is the height of the prism. So it's 19, not 7, plus 2 times the area of the base. This is where we take the side trip. We have to go find out what shape the base is, find out what the area of that shape is. The base that we were working with right here is a triangle. So the area of a triangle equals 1/2 the base times the height. Area equals 1/2. Here's the base, 12. And this height is the height of the base because that's all we're working with. So the area of the base is 42 square inches. And that's our side trip because we had to find the area of the base. The base was a triangle. We found the area of the triangle was 42. Somebody do this one?
Okay.
Surface area equals, we're looking at 600 something. 608 plus 84. 84 is here, 600 is there. Tells us to add surface area now is going to be 692 inches squared. Is that the answer on the back?
2.
Yes.
Okay. Okay, so we're good. Number 5. That was number 5. I want to move on to page 9. This is the surface area of cylinders. Surface area of cylinders, and this is MS1. Up at the top it says MS1. If you numbered your pages, it is number 9. MS1. Surface area of a cylinder is different. And just as a side note, because a cylinder is curved, you're going to be dealing with the number pi in your formula. So the surface area of a cylinder is 2 pi r h, I think,
Yeah.
plus 2 pi r squared. This is what should be in your formula chart. Surface area of a cylinder. Now the cylinder, I guess I ought to draw it, huh? "15 inches here, and the height is 28 inches. And that's all we need. Now, probably the biggest problem that you would have here is mixing up whether this is a radius or a diameter. Always look to see what they gave you, because in the formula it wants r, the radius. If they give you all the way across, you're going to have to divide it by 2 to get the radius. All the way across is the diameter, and we don't want the diameter in here. Okay, and so we're just going to fill out the formula. This one's relatively easy. It doesn't have any side trips or anything. So 2 times, and again, I've said this over and over and over again to you, but look in the instructions. If it tells you to use 3.14 for pi, then do it. If it doesn't have anything in the instructions on what to use for pi, then use the pi button on your calculator, okay? The pi button, because the pi button will give you a more exact answer. Everybody? Okay, but in this case, on this page, it says to use 3.14 for pi. So we're going to use 3.14. All of these are times when they're crammed together. The next thing they want is the length of the radius. And the radius, the definition is halfway across from the center to the outside. So the 15 is the radius in this problem. So times 15, and then times the height of the cylinder. The height of the cylinder is 28. Then the plus, you're just following each step. 2 times our 3.14 again, times the radius squared. Looks a little bit scary, but you have a calculator. Let me get everything. There you go. Okay, those of you on the recording, it went way over, okay? So now, this is going to come out 90 something here times this. So I've got 2 times 3.14 times 15 times 28. So this part is 2637
I got 420.
You got something different? Did you do 2
Yeah.
times 3.14 times 15 times 28? Okay,
No, I messed that up.
all right. And 2 times 3.14 times 225. So this one is 1413. And then when we add these together, we get that the surface area equals 4050.6. Now, as soon as you get the answer, especially if it's a fill in the blank on your test, as soon as you, get the answer, what you need to do is go back one more time and look at your instructions and see if they want you to round it. This one does not say anything about rounding. And so the answer on the back, this is it. Okay, this is the answer. We're dealing with inches and we're dealing with area. So it's inches squared. Area is 2-dimensional. Any problems with this one? Again, there's nothing out of the ordinary and there's nothing new about the cylinders. So I'm going to go on quickly to the next page. The next page does not have anything different. What they did here is just mix up a bunch of different ones so that you could remember which formula to use. This is the sheet up at the top. It says L1 ES1. L1 ES1, and it's a surface area of prisms and cylinders. Okay, if you numbered your page, it's number 10.
Mine's off.
So I'm not going to do anything on that page. We've already done examples of all of those. And again, the next page. Now, the only one on this page that you may question, we've done this one, we've done these. This right here on number 5 is a parallelogram. The base is a parallelogram, okay? So you will want to look for the area of a parallelogram when you do the area of the base. This number 6, the base is a trapezoid. So when you find the area of the base, you'll need to look up the area formula for the trapezoid. Okay? Other than that, here's another trapezoid here. And was there another parallelogram? No. Only one parallelogram, 2 trapezoids on here. Okay? So be careful what shape the base is when you find the area of the base. Any questions on that one?
I just need copies of those.
Do you? Okay. All right. Now here is one of the pages that I need to talk to you about. Let me double check. Okay. This is a page we talked about before. This is the page, it says surface area of a cone. Up at the top, it says ES1, integers ES1. Okay, now I'm going to show you 2 different ways to get this because we've already talked about one way, but the formula chart gives you another way. Are we good? Okay, so we're going to look at a cone. We want the surface area of a cone. No, I think there's just one way.
That's the big B. No, that's for volume. Never mind.
No, there's just one way.
Yeah.
And we're going to use the formula from your formula chart. So I'm going to do one that's sitting up straight so you'll get the idea. So I'm doing number 5 on that page. Now, if you'll notice on this cone itself, it did not give you the height, right? And when we were finding the volume, we had to use Pythagorean theorem to find the height. Okay, and that's in one of our YouTube videos, or you can ask me about it. But today we're finding the surface area of a cone, the surface area. Let me make sure I don't have that one memorized, so I want to make sure I write it correctly.
Pi.
So it's pi times r times s plus pi r squared. Okay, and the only thing on this problem that is new is this s right here. Now, when we're talking about a cone, the S stands for the slant height, the slant height. If we were talking about the perpendicular height, it would be H. But the S in this formula is the length of the slant height. So we want the height that is slanted up to the point. So in this case, we're going to say the surface area equals 3.14. I think that's in the instructions, right? Yes. Times, now the radius, and when they want the radius, double check and make sure you're using the number for the radius and not the diameter. The radius is from the center to the outside, so that is the radius. So times 10 times the slant height, which is 24, plus 3.14 times the radius squared. Okay? And then all we have to do is the multiplication. We're going to multiply here, and we're going to multiply here. This one's 314 plus 4 times 753.6. And when we add that to 314, our total surface area equals 1067.6. We're dealing with yards. And we're dealing with area, which makes it squared. A new formula, but the only thing that you have to be aware of is what the S stands for. And the S is our slant height, not our perpendicular height. Yes, ma'am.
Why do you put 24 on the slant height?
I can always count on you, Vanessa, right? You did great, and thank you for that. She said, why did I put 24 on the slant height? Because the slant height is 20. I bet y'all caught that too, which changes everything. Thank you. Thank you, Vanessa. I love it when y'all catch my mistakes.
I kind of saw kind of off, but I was like, okay.
You thought it was off too, huh? So this should be 628. Is that right?
Yes.
Okay. And then 940. So it should be 942. Is that better? Is that what y'all got? Oh, good. Okay, and thanks to my students, okay, we got it correct this time. Did y'all think I was crazy? My remote students? Do you think I was? What, Christina?
I couldn't see the number, so I was going by what you were saying.
Oh, okay.
Let's see.
Yes, I put 24 here for the slant height, and the picture says, so I don't know. I'm just making up my own, I guess. A little confusing. Are we good? Okay. Y'all have what you need off of that example? Josh, I know you're muted. Are you okay?
Yeah.
Josh, you okay?
Yes, can you hear me?
Okay. And so, as we move to the next page, which is page 13, it's exactly the same thing. It's finding the surface area of cones, but they're letting you use decimals. Okay, so I am going to move on because I want to deal with the last, I think it's, no, next to last page. Okay, the next to the last page has spheres and hemispheres. And we're finding the surface area of spheres and hemispheres. Up at the top, it says MS1, and it is page 14 if you numbered them. Okay, are we good? All right. So looking at your formula chart, find out how we find the surface area of a sphere. Surface area of a sphere. A sphere is three-dimensional. It's like a basketball, tennis ball, golf ball, whatever. A sphere is three-dimensional.
Here it shows 4 surface area, 4 pi radius, arc,
Mm-hmm.
and then a square.
Is it cubed?
Yeah, cube.
No,
Oh,
it's
no,
squared.
square. It's
It is
cube.
squared in it because it's area. 4 pi r squared. That's the surface area?
Yeah, that's it.
Okay, I just wanted to make sure that I don't say the wrong thing. All right, and we're going to skip number 1 because that's a hemisphere, and I'll get to that one next. Let's go to number 2. No, let's go to number 3. Number 3 on that page. It says 44 somethings feet. 44 feet. So what we're going to do is you write down your formula first. This is to help you not mess up. Write the formula first and then start plugging things in. So you have surface area equals. Now there's 4 in the formula, so you have to use the 4. When things are crammed together, it's multiplied. Our instructions say to use 3.14 for pi. So I have 3.14 times, and I need the radius. What's the radius? 22. Good. It's 22. The picture shows 44, but the radius is only halfway across. 44 is the diameter, so 22 feet is the radius. Now you got to be careful because I guarantee they'll do it on the test. Times 22 squared. Now, if you're using the order of operations, you need to do this first. And so I think it's 242, is it? No, 444. 4. There we go. My bad. 484, we do that first. You can do the rest of this in your calculator. And your answer should be 6079.04. We're dealing with feet, and we're dealing with area, and so it's squared. Are we okay here?
Yeah.
You just use the formula and you're careful about diameter and radius. All right?
Measure from the middle. From the circle.
Say it one more time.
Just measure from the middle from the circle.
Just from the middle to the outside is the radius. Yes. Yes. Okay, now this is important. Well, all of it's important. Silly me. Okay. When they talk about a hemisphere means half of a circle. Half of a sphere, okay? So this first one says 23, I think. 23 inches. Now, we found out, and I don't know if you remember, but when we were working with volume, we just found the volume of the sphere. And if we wanted a hemisphere, we just cut it in half and divide it by 2. And that was the answer, right? That does not work for surface area, and I will show you why. Okay, let's go ahead and find, this is the whole sphere. We still need to find the entire sphere. We still need to do that. So our surface area for, if we were finding the whole thing, is this formula. So surface area equals 4 times 3.14 times 23 squared. Are y'all okay with this? To find half a sphere, you've got to find the whole sphere. 4 times 3.14 times 23 squared equals 6644.24, and we've got inches squared. Now understand that this surface area that we just found is the entire sphere. That's the whole sphere. So if we want half of it, we're still going to have to divide by 2, okay? So let's divide by 2 to get the hemisphere. 3322.12 inches squared. Okay, that will be half, but here's where the change comes in, okay? The surface area, remember, the surface area is the part that you can paint, right? Okay, so when you found the entire sphere, that means you paint the outside of the ball, right? And when you cut it in half, you're still painting the outside of the ball. So this answer will only give you this much. It only has you painting the outside of the ball. But now that we have cut it in half, there's some more stuff to paint. Y'all see? And so what I have to do here is I have to figure out also this area. Now the area of a circle equals pi r squared, correct?
Yes.
So to find a hemisphere, I've got to find half of the sphere plus the area of a circle. Because when I halved the sphere, you guys understand what I'm talking about, right? when I cut that sphere in half, I only painted this much of it. So I've got to also find the area of the circle, because I'm going to paint that now and I wasn't going to paint it before, right? So I have to add pi r squared onto this. So pi times 23 squared Irene, you're going to like this because when I get done with all this explanation, there is a shortcut. Okay?
I'd rather have a shortcut.
Well, you listen to me. Okay. So I have 3.14 times 23 squared.
It's
Uh-oh.
1661.
And pi.
Yep. So this part right here is 1661.06. This has to be added on now. This is the outside of that sphere, and this is the center circle. And so we're going to add those together now, and we have 3322.12. And so the surface area of the hemisphere right here, we found this by finding the sphere and dividing by 2. Then we had to add in this circle that I'm going to paint, and your surface area answer should be 4983.18 inches squared. So you will find out that if you just find the surface area of a sphere and you cut it in half, you'll get the wrong answer every single time. It'll work for volume. It does not work for the surface area. Make sure you have all of this and that you understand it, and then I'm going to give you a shortcut. Okay? Yay. I just want you to understand what's happening. Now watch this. This is so cool. Everybody get this? Do you understand it, y'all? Do you understand why it's different?
Yes.
Okay,
Yes,
Josh,
ma'am. Yes.
Isabel? Sorta?
Yes.
Okay, now you guys are gonna like this. Okay, what we're gonna do is mess with the formula just a little bit. And the reason I wanted you to understand what we just did is because you will understand what we're doing when we mess with the formula. Okay, here we go. To find an entire sphere, we did this, correct? The next thing we did, because we wanted a hemisphere, is we just divided by 2, right? So I'm going to divide this by 2. But then we found out that we still needed to find the area of that circle, right? So we added on pi r squared. We added that onto the formula. And Irene's saying, that's not much of a shortcut. I'm not done. Watch this. Watch this. 4 divided by 2 is what?
2.
Divided by 2.
2.
It's 2
Two.
pi
It's
R.
2.
squared, correct?
Yes.
Plus pi r squared. So here are 2 of the pi r squareds, and we added 1 more pi r squared to it.
Oh my God.
So your shortcut for the surface area of a hemisphere is 3 pi r squared. 3 pi r squared. That's how you find the surface area of a hemisphere. Okay?
All right, let me write write this
So
down.
make sure you write that on that page or in your notes. It is not on your formula chart.
And this is for him.
It's for the hemisphere. Surface area of a hemisphere. I think this may be the last thing that we're going to talk about today, but I'm going to check my pages. This is for the surface area of a hemisphere. It does not work for volume. Surface area and volume are two different things. For the volume, just find the area of a sphere and divide by 2. No big deal. Surface area is different. Let me see if there's anything else. Triangular square pyramids. Okay, in the interest of time, what I'm going to do for pages 15 and 16, these are the last two, it's to find the surface area of a square pyramid. Square being the operative word here. That means the base is a square. Okay? Surface area of square pyramids.
I got it.
Gotta go?
I gotta get ready for work.
That's okay. Check this YouTube and I'll give you the formula for this one. And do you need the pages?
Nah.
Okay.
Okay.
All right. See you later. Bye-bye.
Bye.
Okay.
I
And
got
then
it.
your last page says the same thing, but it says surface area of a rectangular pyramid. Right. Believe it or not, they're the same formula. Okay, so I'm going to give you the formula, and then if you still have questions, be sure and ask me. Yes? Okay. So the surface area of a rectangular or a square pyramid, surface area. This is for square pyramid or rectangular. Pyramid. The formula is 1/2 the perimeter of the base, and be careful, the bases are either a square or a rectangle on these last two pages. So the perimeter of the base times the slant height. Remember the S is the slant height plus, and then you need to find the area also of the base, and the base again will be a square or a rectangle. This is how you find the surface area of a square pyramid or a rectangular pyramid, meaning that the bases are either a square or a rectangle, and they come to a point at the top. It's a pyramid. So this is the formula, and in the interest of staying on here way too long, I want y'all to have time to practice. Tomorrow, we're going to start graphing. We're going to start geometry, and we're going to start all the way to the definition of points, lines, planes, rays, segments, angles. And after that, we're going to plot points on a Cartesian coordinate plane. And then we're going to plot lines, and then slope. Okay, so the rest of this week and next week will be spent on slope and lines and graphing. All right? Everybody okay?
No.
Okay.
It's a lot, so it's time to practice. Okay? So I will finish this and we will see you tomorrow.
Okay, bye.